Okay, we want to talk about something that we review because we just did a midterm and it was a take-home midterm because of the coronavirus. And somewhat surprisingly, people who had really pretty good solid papers didn't correctly graph a given quadratic function. Okay? So, you first vertically stretch, then you translate the origin to the vertex. This course requires that you know how to identify the vertical stretch. There wasn't one on the problem we had on the test, so I'm not going to talk about that. But then you translate the origin to the vertex, and people didn't do that. At least some people that had pretty decent results on the exam, the midterm, didn't do this. We spent a lot of time doing this, which is why I'm a little bit surprised. Okay? Now, to translate the origin to the vertex, okay? I'll say that's it. Of course, you got to find the vertex. Which occurs at x equals negative b over 2a. Okay? Now this is assuming a quadratic function in the standard form y equals ax squared plus bx plus c. This is review. I'm not going to state all the conditions. It's all done repeatedly and correctly and meticulously in videos from early in the semester. Okay? Just reminding you, there's where your vertex is. You find the y-coordinate of the vertex. By plugging in x equals negative b over 2a. I won't, people did things like this. You got y equals x squared minus 5x plus 7. Here's your horizontal shift. Here's your vertical shift. No way. No way. If you make a table of the function that you think you have when you do that horizontal and vertical shift, you're not going to come up with pretty much any points on your graph except maybe one. It's not going to be consistent. Your vertex is not even going to be, you would say then that the vertex should be at negative 5, 7. Okay? Well, if you make that assumption, you're going to find that it's not so. Point negative 5, 7 isn't even on this. Okay? X equals negative 5, y equals 25 plus 25 plus 7 equals 57. And you can verify that, plug negative 5 in, and you get this. Not 7, which would have to be if that point was on the graph. Okay, so this point is clearly not on the graph, and this is clearly not what you do. You have to remember this, which is an elegant, simple way to do it. And you're going to have to learn how to get this by completing the square also. Now, this is a much simpler way to graph a quadratic function by transformations.